Hello, this is Lothar Lippert from Genius Graphics, TechPlot partner in Europe. I'm going to give you an overview on the features that TechPlot provides to visualize vortex, cores, vortices, and streamlines. What you currently see on the screen is a dataset that I'm going to use for that demonstration purpose. It's the flow around a little rubber flap. See here that flap, and behind that flow you see some vortices. It's a transient dataset, so we have different time steps. We can move through the time to see how the vortex core moves in time and how the streamlines change over time. I'm going to start from scratch with the blank TechPlot screen that I have here. And I will load a dataset that is a fluid structure interaction simulation coming from Fluent. So I'm using the Fluent data loader within TechPlot to load that dataset. I'm in the Elastic Flap 3D sample, and I'm going to load several time steps all at once and do an open file. So what we see here now is the raw dataset. If I move through time, you see that little rubber flap in the middle moving. And we are now going to format the dataset a little bit, so I don't want to see the shades. I'm going to remove that lines between the different blocks. So I'm switching my edges to creases. And that's it. So the first thing we want to see is basically the vortex cores, and one of the first features we can use here within TechPlot is the Analyze, Extract Flow features. We can select the vortex cores here, and then we can extract the vortex cores. Currently there is no feature to extract vortex cores over time, so we need to manually go through the different time steps and extract the vortex cores. Or we can use scripting, record macro, to record a macro that loops over the different time steps and extracts the vortex core for each different time step. Currently, for now, I'm just doing it manually. I'm doing an extract, and you see a vortex core appears as a line on the screen. Now I'm going to the second time step, do an extract, third one, extract, fourth one, extract, 6, 7, 8, 9, 10, and the last one. Okay, now we do have, when I click on the zone style dialog, we do have a vortex core which is marked with a little star here. That means it's a vortex core object that exists over different time steps, and moving through the different time just by using the mouse will show you how the vortex location changes over time. In order to make that vortex a little bit more visible, I'm going to click on it. I will take the mesh color, change it to red, and make the little vortex core a little bit thicker so it's easier for us to see where it is. Okay, now we can see the movement of the vortex core. Visualizing vortex cores, you can do several things within TechPlot. One thing is basically you can turn on a slice. You can move that slice to locations where the vortex core hits the slice, like here in that region. And if you want to visualize streamlines, we just click on Stream Traces here. TechPlot will propose the vector components to be used for the stream traces. And then just by clicking on that slice, where the slice hits the vortex, and maybe move the slice a little bit to a different area, like here. Oops, sorry. Like here. We can place some lines, and you see they twist around the vortex core. So that's actually one way of visualizing that, and we can change the slice orientation by just clicking on that Add a Slice tool. Click on Y. So we can move the slice into the Y direction and probably just place a few more in the Y area. So turning on the slice or turning off the slice now shows us the vortex. And if I go through the different time steps, you see how the streamlines are calculated, or they are going to be calculated again. automatically, so you don't need to place the streamlines all the time. That's another way to visualize the vortex. If you want to do a little bit more on the stream traces, let's turn on the slice again and click on the stream trace dialog. Another way, instead of using the volume line, is, for example, volume ribbon. Volume ribbon allows us to place a stream trace, and what you see is a ribbon, as it says. So you see a ribbon twisting around the vortex core, and clicking on the 3 points here into the rod and ribbon dialog allows us, for example, to turn on and off the mesh on the ribbon, or to color it by a certain variable. In this case, we just color it by pressure. Same for the lines. The lines are by default black, but the lines can also be colored by any variable. For now, I just want to have them black. If you want to animate stream traces, you can do that. Just go to the timing dialog, turn on, for example, markers, color the markers by a variable you'd like to have. And then if you want to see less stream traces, maybe use a factor 10 less, so maybe a factor 4 is enough. And now we have some markers that can follow the stream traces, and by animate stream traces we can just play a little animation about the stream traces going around the vortex. Okay. Next way is we turn off the slices, and I'd like to now use eigenvalue to visualize an isosurface around the vortex core. To do that, you see a tool, Tensor Eigensystems, that we are going to use. Clicking on Help brings up a help menu that shows you how to do that. In fact, what you need to do is you need to calculate a couple of new variables, so you need to copy and paste that here into a file. I'm going to show you that file later on. Then you need to calculate the velocity gradient using the analyzer module in TechPlot, and then you use that tool here to calculate the symmetric tensor. And then you are getting a new variable, lambda 2 or eigenvalue 2, in the middle of the 3 eigenvalues that you can use to visualize an isosurface. So let's do that now. First step, calculate velocity gradient using analyze calculate variables. So I'm going to the analyzer module here, analyze, calculate variables, select, and we see the velocity gradient down here. So I'm selecting that. I turn off calculate on demand because I want to do that for all the time step at once. Calculate on demand means whenever you change a time step, the calculation will start, but the data set is small enough to do it for all the time steps immediately. So I do a calculate. Calculation was successful, which is good. The second step, calculate the symmetric tensor using data alter specify equations. So we are now using those equations here. So I'm going into the data alter specify equation dialog. You see we don't have any equations here. This is where I load an equations file. In fact, the file is here in my temp directory. I think it's called tensor, and this is the file we are going to use. So I just copy pasted the alter data equation from the help menu into that file. And I'm now doing a load equations, means I'm going to the directory where I stored that. All files, tensor, and here we go. We have our equations here. And now I will just compute those equations. Successful means now we have in the dataset information calculated a number of new variables. You see them here. And now we need to fill in the tool Tensor Eigensystem with those components here. So here we have S202, 1, 1, S202, 1, 2, S2, 1, 3, 2, 2, 2, 3, and finally 3, 3. Of course, all those operations can go into a macro, so you don't need to do that manually. Currently, that's requiring a few more clicks than it should. We are working on that. So I'm clicking on OK. The calculation is done. And now we see we have new variables, eigenvalue 2, variable number 69. And I want to use that variable as an isosurface. So what I do is I'm turning on a slice. Again, you already know that slice. I'm clicking on the 3 points here to open the slice dialog, and I want to see a contour based on the variable eigenvalue 2. Okay, here we go. Currently we just see a red slice, but I need to add a few more contour levels, and you see a legend has been turned on. It's here, eigenvalue 2. And I can basically just use that tool, add contour levels, and interactively click on the slice to color the slice by that eigenvalue 2 variable. The point is, I need to find a value that I'd like to use for my isosurfaces. So one way to do that is basically I can just click using that tool to probe data onto my data set, scroll down to see the eigenvalue value. Here we go, minus 230,000. I hope that's a good value, at least for that time step. And then I'll turn on isosurfaces. I want to base the isosurfaces not on pressure but on eigenvalue 2, and I'm going to use the value we just extracted. Okay, now we see an isosurface that already includes that vortex. So we can turn off the slice. We don't want to see it anymore. We go to our style dialog here, make the isosurface translucent, and here we go. We are now seeing an isosurface that includes that vortex core. Going through the different time steps, you see that in the first time step the vortex core and the surface are quite matching very well. Here's the second one, also matches quite well, and the third one. So all that is quite nice actually. The isosurface itself currently is colored by pressure. Maybe we don't want that. Maybe we want to have a homogeneous color, so we color it by eigenvalue 2, which is a fixed value for the isosurface, and that's why we have a unique color. So going through the different time steps shows us how the streamlines are being updated, how the red line, the vortex core, is moving over time, and how that isosurface basically includes the vortex core. Finally, if you think that's a nice picture, we double click on the legend and make that a little bit smaller so it's not disturbing our view here. We can, for example, create an animation doing animate keyframe animation, which allows us to append a view. Maybe do that for a different time step. We can create a second view by rotating the dataset, do an append, zoom out, append, rotate it a little bit again, append. And then by doing an animate all, we can basically just with a few mouse clicks create an animation that is already quite sophisticated. Okay, once that is done, other options that may be of interest for you is you can animate the stream traces concurrently. So let me just do an animate all again. You see how the little spheres are following the streamlines while playing that animation. And if you want to go further on in the options dialog, cancel the animation, I can animate the time concurrently, which means if I do an animate all now, you see while rotating we are getting updates on the isosurface, on the streamlines, and we see how the vortex core is moving over time. This is quite a rough mesh, so I apologize. The vortex core is just made of a few cells, like the isosurface here. That's why we see those gaps, but it works very nicely for a finer mesh. Alright, that's all. In case there are any questions, feel free to contact me. Let me write down some contact information for you. Just like that, I will do a text annotation. Contact Genius Graphics or Techplot Europe at +49 9402 9480 and a 0. Just ask for Lothar Lippert, or in case you have technical support questions, please use support@techplot.de. Thank you very much for listening to that video. Have a good day. Bye bye.